Hi, I'm Mike Stanzik, and this is Digital Electronics Classroom. In this video, we're talking about number systems, and specifically we're talking about non-traditional bases. And so our traditional bases are binary base 2, octal base 8, hexadecimal base 16, and then decimal base 10. And so what if we had a base like 4 or 8, sorry, 8's one of the traditional ones, so it's like 4 or 9 or 7 or 3, and ones that we don't normally see, or like maybe like 14 or something. So how would we deal with that? And so we're gonna do a couple of examples of that right here. Hopefully it'll be helpful for you if you have this problem that you're thinking about, or just are trying to expand your understanding of number systems in general. All right, let's get started. So this is non-traditional base conversions. So we're just going to go do a couple of examples here. So we're going to take the number 2025, which is the current year, in base 6, and we want to convert that to decimal. What is that in decimal? So when we convert to decimal from a number of a different base, we use a polynomial, and so we have 2 times 6 to the 3 plus 0 times 6 to the 2 plus 2 times 6 to the 1 plus 5 times 6 to the 0. So 6 to the 3, if you use your calculator to calculate this, is 216. And then this is 0 times 36 plus 2 times 6 plus 5 times 1. And so this is 432 plus 0 plus 12 plus 5, giving us a final answer of 449. And so 449 base 10. So there it is. So it's nothing new. So if this is new to you, that means you have to watch one of the earlier videos where we go through this process of creating a polynomial to create the decimal number from a different base. But if you've watched those, then this is the same process. Now let's go the opposite direction. So say we have a decimal number, and in this case we're going to use the decimal number 555, and I want to convert that into a number that is base 7. Excuse me. So when we go from a decimal number to a different base, we're going to use the process called successive division. And so let's start that out. So 555 divided by 7 is going to give us a integer quotient, 79, and then some decimals. And so we're going to take that decimal part and we're going to turn it into an integer by multiplying it by the base again. So we'll multiply it back by 7. So we're going to take away 79 to give us just the decimal part. We're going to then multiply that by 7, and in this case we get the number 2. So if I make a table of my quotients and my remainders, we have 79, remainder 2. So now I'm going to take that 79 and then divide it by 7, and so then I'm going to get 11 with some decimal, take away the 11, multiply that answer by 7, and in this case we also get the number 2. So we have 11, remainder 2. And then I'll take the 11 divided by 7, and so we have a 1. And you can already tell that 11 divided by 7 gives us 7, remainder 4, but you're going to get some decimals here. And if you take away the 1, multiply that by 7, you're going to get the number 4. So we have 1, remainder 4. Remember, this process is that we keep going until we get a 0 for the quotient. And so we have 1. I'm going to move over here so that my screen and screen will work. So 1 divided by 7 gives us 0, and then some remainder decimal here, that's 1/7. And so if we just take that and multiply it by 7, we get back 1. So there's going to be a remainder of 1 there. So this is 0, remainder 1. And remember that we read from bottom up. So read in this direction. So we have 1, 4, 2, 2. So 1, 4, 2, 2, base 7. So 5, 5, 5, base 10 is 1, 4, 2, 2, base 7. And that's it. So whatever base that you have, you can go back and forth using these processes of writing out the polynomial or using successive division. One more thing that I would caution you on is if you have a base that's greater than 10, then you're going to have to substitute alpha characters for the values that are 11, 10, 11, 12, so on and so forth, because they require 2 digits and we want to make that just 1 character. Okay. Thanks for watching. I hope this was informative for you. Have a nice day and we'll see you next time.